and welcome back to my channel Science with Chris. I'm Chris Adam and today I'm going to show you some fascinating experiments which will surely blow your mind. And I request you all to put in your seatbelts because soon we are going to enter the world of science. And I'm not only going to show you the experiments, but I am also going to explain you why did they happen. And now let's move on to our experiment. Okay, for the first experiment, all you need is just a paper or a plastic cup, and all you have to do is rub this paper or plastic cup with your hair like this, and then you will have to take this paper or plastic cup near the water and see what happens. You see that the water got attracted towards the plastic cup. It seems like the water is bending, but it's not actually bending. It's kind of repelling from the plastic cup. Every substance of this world contains equal number of positively charged and negatively charged particles, which we know as ions. The charged particles of any substances is known as ions. There are equal numbers of positively and negatively charged particles, so they are electrically neutral. And there is no exception for a plastic cup or the water. They are also electrically neutral. But when I rub the plastic cup with my hair like that, what happens is the negatively charged particles of my hair get transferred to the plastic cup, and the plastic cup becomes negatively charged. So when I take the plastic cup near the water, what happens is the negative and negative charged particles always repel. So the negative charged particles of the water get repelled from the negatively charged particles of the cup. So the negatively charged particles try to get away from there. So it's kind of bent. So all the negatively charged particles are gone away. Only the positively charged particles of the water and negatively charged particles of cup are left there. So we all know that the positively and negatively charged particles always attract each other. So the positively charged particles of the water and negatively charged particles of the cup attract each other. So the water seems to get attracted towards the cup. There are lots of phenomena to describe this thing. Like you can just take a balloon and then you can rub it with your hair, and then you can see that the balloon sticks with your hand to the room walls and so on. Okay, now it's turn for the experiment number 2. For the second experiment, you just need a bucket and a rope. The procedure for the second experiment is very simple. All you have to do is take a bucket, take a rope, and then tie the bucket with rope like this, and then fill the bucket with water, and then try to move it in a circular direction like this, but wait. Here's a precaution for you. Before you directly try to rotate it in the circular direction, you try to gain some momentum by oscillating it in to and fro direction like this. You can gain momentum like this, because if you didn't gain enough momentum, what happens is when this bucket goes to this position, there will be enough or more the turning effect on the bucket, so there is a high chance for the water to spill out of the bucket. So you better gain some momentum before you try to rotate the bucket. So now I'm going to show you how to perform the experiment. Do you see that? Besides, the bucket was in upside down position and gravitational force was acting upon it. It didn't fall. The water didn't fall. Why did that happen? To know the secret behind that phenomenon, you must know about two types of force. That are the force that acts upon a body moving in circular direction, and next, gravitational force. There are generally two types of force acting upon a body moving in circular direction. One is centripetal force, whereas another is centrifugal force. Centripetal force is generally the force which acts from the path to the center of the circular path. Whereas next is centrifugal force, and it is the force that acts upon a body moving in circular direction, but it acts from the center towards the radius, and it is extended as the radius of the circular path. And next is gravitational force. We all know about gravitational force. It is the force of attraction which pulls a body towards the center of the planet, of Earth, or any body having mass. Okay, now you knew about all the forces that acts upon a body moving in a circular direction or a freely suspended body. But the question remains, besides the bucket was in upside down position and the gravitational force was acting upon it, why didn't the water fall? Besides the body was in upside down position or the bucket was in upside down position, the water didn't spill out of the bucket. Because when the bucket was in upside down position, there were two types of forces. One the centrifugal force and next the gravitational force acting upon it. Centrifugal force always wants to push the body, and or let's say a body which moves in circular path is always affected by the centrifugal force as it is extended towards the radius, or it is extended towards the radius, right? And next the gravitational force. Gravitational force always attracts the body towards the center of the planet or any body having mass. So when there were two opposite forces having opposite intentions, what happens is when there are two equal forces exerted on the body, when the centrifugal force and next the gravitational force, there was equal amount of force exerted on the bucket. So what happens is when there are equal forces, they cancel each other, and there is no force left. So there is no force to pull down the water. So the water is still, it remains still in the bucket, and it does not fall out of the bucket. Okay, it was all about today's video. If you like the content of my video, please like it, please subscribe my channel, and I will be back soon with same kind of videos. Until then, stay home, stay safe, and of course, stay curious.